So just continuing from the previous video on cantilever beams, we have another problem here, which is slightly different from the previous one we discussed. You again have a cantilever beam which is supported, fixed at this end, and you have two point loads acting at 2 meter and 4 meter from the fixed support. So you've got 5 kilonewton, 5 kilonewton acting at, say, A, B and C. So the loads are acting at B and C, which are separated by 2 meter, and the point load at B is at a distance of 2 meter from the fixed support A. So all the force equilibrium and moment equilibrium should come from this rigid or fixed support of the cantilever beam. Now, as from the previous video, you have a summation of all forces in y direction equal to 0 for force equilibrium, which gives you a reaction at A minus 5 is equal to 0, or reaction at A is equal to 10 kilonewton. So just following on from the previous shear force diagram creation, you have your shear force diagram here. At point C, you have a 5 kilonewton acting downwards, so you have a minus 5 kilonewton, and between point C and B there are no loads acting. Therefore the 5 kilonewton continue until the point B here, at which point you have another 5 kilonewton, so minus 5 kilonewton, and total you have a minus 10 kilonewton here, and that will be compensated by the reactional force of 10 kilonewton at point A. So that's your shear force diagram for this particular case as the shear force area. So let's move on to the bending moment, and as in the previous case, we are going to create a bending moment equation. So let's take a section here, section x, and let's say this distance is x between C and our section here. So for the bending equation, you have a bending moment at about xx is equal to this 5 kilonewton creates a counterclockwise moment, a clockwise moment about this point, and this 5 kilonewton creates another clockwise moment about this point. So you have this 5 kilonewton at x, acting at x from this point, and this 5 kilonewton acting at x minus 2 from this point. So you have 5x, so we consider both as negative loads, 5x minus 5 times x minus 2, that is the bending moment, and you give x equal to 0. At x equal to 0, you always, whenever there is a x, you substitute x here and you get a number of minus 2 here, so you discard this term. At x equal to 0, the bending moment will be minus 5 times 0 minus 5 times 0 minus 2, so that will be again 0, because whenever there is a negative term within this bracket, you should discard that value. So that is discarded, and therefore this entire term becomes 0. This term is already 0, so you don't have any moment at x equal to 0, and your next point is x equal to 2. Let's say at x equal to 2, you have minus 5 times 2 minus 5 times 2 minus 2. So 2 minus 2. So that this term becomes 0, and you have a bending moment of minus 10 kilonewton meter. And the third point is x equal to 4, which obviously is this point here. So the maximum bending moment will occur at that point, and at x equal to 0, your moment is minus 5, oh, sorry, at x equal to 4, your moment is minus 5 times 4 minus 5 into 4 minus 2. So that will be minus 20 minus 10, that is equal to minus 30 kilonewton meter. And your reactional force will compensate for that. So you have at this point at B you have a 10 kilonewton meter, and at A you have a 30 kilonewton meter. And because all these, because this bending moment diagram is governed by x, a linear relation between x and the force, there will not be a curve, it will be a straight line between the changes of bending moment. So at this point you have 0 kilonewton meter, at 2 meter from the end you have 10 kilonewton meter, and at the 4 meter distance you have 30 kilonewton meter, and all these force will be compensated by the reactional force at the end of the cantilever beam or at the fixed support. So that constitutes your bending moment diagram for this particular case. If you have any doubts on this problem, please comment in the comment box, and we will try to get back to you as soon as we can. Thanks again for watching, and keep watching for more videos on cantilever beams, shear force, and bending moment diagrams. Thank you.